Welcome back. So we're going to do an exercise on the big data framework with Spark. Although, again, as I said in the previous video, so this exercise is going to be focused on a very tiny data set. Okay, actually, we are going to manually create the data in our code just to demonstrate the case. So even though it's um, for big data exercise, we are going to just use a very tiny data set. So this is the first thing I would like you to know. But the purpose again here is for you to learn, to understand the basic ideas associated with this framework. So for this exercise, you need two things. One is that you definitely need a Google account because we are going to use some Google infrastructure for this exercise. The first is the Google Drive. We are going to have to do some configuration and data access on Google Drive. Okay, so if you have a Google account, I suppose you do, go to drive.google.com and then under your My Drive, create a folder for this exercise. So I would say create a folder such as big data or something like that. So I already have that. If you don't, go ahead to create a folder and name it big data. So we are going to place things in there. Okay, so this is the first thing. And the second is that you need access to Google Colab. Collab is the environment that is very similar to a Jupyter notebook where you can execute and document your analysis using Python. Okay, and so in this exercise, we're going to create a new notebook in Collab and run it on the Collab environment, set up the necessary connections to a Spark environment in the Google Cloud with Python, and then be able to execute and test some of the things we like to do with Spark. So these are the two things you need to have access to. As long as you have a Google account, you should be able to do that. Okay, so now let's get started. And so once you are here at in the Collab environment, go ahead to new a notebook. And so hopefully it's working. And I'm going to name this notebook small data. So even though even though we are going to deal with a big data framework, we are using small data for the demo. Now, it takes some configuration, so we have to spend some time setting up the environment before we can do something meaningful. So let's be patient here. Okay, so just a piece of warning. Let's be patient and we can conduct some configuration. So the first step that we'd like to do is just to put some text here just to describe what I'm going to do here. So the first step is definitely just set up. Okay, so here we are going to set up the PySpark environment with connection to the Spark. And so we are going to import, first of all, Drive, so that we have access to Drive. We can download certain packages we need for Drive and be able to install related packages so that we'll be able to connect to Spark from Python. Okay, so first let's import Google Colab from Google Colab, the Drive access. Okay, and then from Drive we can mount the /content/Drive. this will give us access to the Google Drive environment, okay, where we can save data, save packages that we want to install there. Okay, so I'll run this. I have already granted access for Collab. Okay, so if you haven't done so, it's going to ask you to connect and grant access to Google Drive. So click on connect to Google Drive, and you have to allow it. Okay, so that's allow it. Okay, so once that is done, depends on the environment. So once it's done, you are ready and you have access to the Collab, to the Drive environment, Drive from Google Colab. Okay, so here in the Google Collab, just for you to show you that I have access to it, I can actually run the test to unzip this file. Okay, so if you want to do this test, feel free to do it, but this is not required. So I just want to show you that I do have access to Collab. So here I have a test.txt.zip. So if I can run a command to unzip this file and show the text, then it means I have access from Collab. So I'm going to do it with a command line, such as, so when you try to run a command from the Collab environment, you use this exclamation mark unzip, and then the path to the file. So in my case, I have I place a zip file under big data under my drive. Okay, so my drive is under /content/drive, and then my drive, and then big data /test.txt.zip. Okay, so and then I'm going to unzip this file to this particular in the same folder. So let me just be explicit about this. So big data / okay, so I'm going to unzip the file and output that file into the same folder. So you can either run using this icon by clicking on this button, or shift enter, and it's going to run it. And so let's see my drive. So as you can tell, if you go back to the Google Drive, you will see that this file has been unzipped from the zip file, and when you open it, you will see that it shows the content. So if you have a zip file, you can try it and see if you do have access to Google Drive. I think here, because I already have an existing file in there, it's asking me whether I want to overwrite, so I can actually overwrite the file, kind of the temporary file. Okay, so so that means things are working, so we can continue from here. And the next step is to download some package from Spark and install it in our Google Drive, so that we have access from Python to Spark. So if you just Google it, Apache Spark download, you should be able to find it. Okay, and I have tested this earlier version, but I'm certain you can try the latest version. But 3.1.3 is something that I have tested, so I'm going to select this particular Spark release, and then click on download Spark. So when you click on download, it actually shows you the link to where to download this Hadoop Spark. Okay, So what I would like to do is to right click and copy link, okay, because this is the download link, and instead of downloading it to your machine, we want to download it to the Collab, to Drive, Google Drive, so that we can install that package on Google Drive. So let's do it. So exclamation mark wget q, and I'm going to copy and paste that link, okay. And what I'm going to do is that I can actually redirect this download to content / drive / my drive / big data, okay, so that this file, this Spark Hadoop package will be downloaded to the big data folder that I have created on my Google Drive. So let's give it a try. So hopefully it's going to download. I think it's done. Okay, so the package is here in the Google Drive. The next step is that we need to unzip it. Okay, so let's run tar x xvf, and then we need to unzip this particular file, which is /content /drive my drive /big data and then the name of the file. So I think we have the file here, okay. So this should be consistent with the file name that you have downloaded here. Actually, when I already downloaded the file and I download it again, so it makes another file. So either way should be fine, okay. So I'm going to unzip this file. So this tar/zxvf is to kind of uncompress the file, okay. So it may take some time, so let's run it. Okay, it will show you the output when it's unpackaging the file, and I think it may be done. Okay, so again, this can be a bit tedious at the beginning, but hopefully we'll have some fun when we have the package ready. So it's done. I'm going to remove the output, just to clear the output so that I can show you the next step. So after we unzip it, we can use PIP. PIP is a Python package manager or installer that help you install certain Python packages. So I'm going to install the Find Spark. Okay, again run it. Okay, so install Find Spark so that you will be able to find the Python, the Spark environment from Python. Okay, so right now at this point the setup is done. We can start to test, you know, so we can start to connect Python to Spark. Okay, so this is the next we are going to do is first we need to find where I'm sorry, there's one more thing. So I just there is also a Java environment you will need to install in order for things to work together. So you use apt-get installed open JDK 8 JDK headless QQ. Okay. So don't worry about what the parameters actually mean. This simply installs the Java environment for the setup. So we do need this for the whole thing to work together. So take your time to make the installation. Okay. Okay, so once all these are done, let's continue to test Spark in Python. Okay, so import OS, and then because we need the OS to set up the environment. Okay, so os.environ, and then Java underscore home, all capital, equal to usr/lib jvm /java 8 open jdk amd 64. Okay, another line, another environment. So two environment variable. One is about where Java is, and another is about where Spark is, right? So Java, we install it using the OpenJDK. Okay, there is the default location of it, so just follow me here. And then for Spark, it should be, when you unzip it, the way I did, it should be under /content and then 3.1 3, right? Bin dash Hadoop. So this is, just follow carefully the version number. Okay, make sure so you compare Spark, the name of Spark dash 3.1.3 to what you have downloaded here, Spark 3.13 dash bin dash Hadoop 3.2. So this should be correct. Let's run it. Okay. So this is going to be okay, but if anything is incorrect here, we'll run into problem later. And so just in case you later run into problem when you try to find the Spark and you cannot find it properly, come back and check these environmental variables. Okay, so next we are going to find Spark, and let's see if we can find it. Okay, so let's use init to initiate the find Spark. Okay, so it goes through. Now from PySpark.sql import Spark, capital S, Spark session. Okay, and here we are actually going to connect, okay, to the Spark environment once we have found it. So Spark session dot builder, put a dash, put a slash, so that we can have kind of split one single Python line into multiple ones. Okay, so with dot master, we can specify that we're going to run it locally in this Collab environment. App name, you can give it anything. Okay, I'm going to just call it small data. Okay, I need a slash at the end of each so that I can connect the next line, and then config. There's nothing special, it's simply here to specify a port for the connection, and then get all create. So this is to say that if the connection is already there, we can simply just get use it. If it's not there yet, we can create this new connection to Spark. Okay, so let's give it a try. Okay, so hopefully it will connect if everything is specified correctly, and looks like it goes through. So why don't you, if it all check, okay, then you can simply in the next code cell you just type Spark and run it. Okay, and it gives you this information about the version and things like that, and it looks correct to me. 3.1.3 is the correct version that I have installed here. So this means the environment is set up properly. Okay, so now we are connected. Let's do some work, and of course we are not going to really again process a huge amount of data such as billions of pages here, but we are going to try some small data, and hopefully it makes sense. Okay, so that's some text. So a big data framework. Okay, so I'm going to start doing some processing here. So right now our Python is connected to the Spark environment. So what I would like to do is that we can start to import some packages in the PySpark and be able to utilize them. So just to give you some context of what I'm going to do here. So I would like to post some piece of data, a few sentences of data with some keywords in there, and I would like to ask the Spark environment to help me tokenize the sentences and be able to identify the keywords, and then in the end we may be able to count those keywords and identify their tone frequencies, document frequencies, and even inverse document frequencies. And if you are not familiar with the notion of TF, IDF, you may want to take a look at related literature or videos about them. Simply put, when it comes to text processing, it's very important to be able to kind of assign proper weights to the terms that we identify or words that we have identified from a text collection, and use those term weights to represent the documents or text data that we want to process. This is normally an important first step. So let's do it. So from PySpark.ml, this is part of the machine learning library feature, because some of the packages that we are functions we are going to use are related to feature representation, event selection. So we are going to import tokenizer, count vectorizer, and IDF, or the inverse document frequency modules from the library. Okay, now first of all, we already established a Spark connection, so we can start to call Spark, and then we can, so for now, just for the sake of demonstration, we are going to create a data frame within our code. Normally, if you are dealing with large amount of data, normally you load the data from your infrastructure, from your distributed storage. Okay, but for now, just for the sake of demonstration, let's put our data in the code. So when you create data frame, there are actually two parameters. The first parameter is the actual data. Okay, so in a set of square brackets. Okay, so what you can have here is that you can put things such as 0.0 and then Python SQL data. Okay, I'm going to enter some of these data and then I'm going to explain what I'm doing here. So data science and data engineering. Okay, so you can see that I'm entering two columns of data in this data frame. The first column, I imagine it's some kind of a label, right? 0 for perhaps one category, 1 for another category, and then the second column is for the actual sentence, right? So Python SQL data, R SQL science, data science, and data engineering. So these are the actual text data, and so so these are kind of two columns and 3 rows of data, as you can tell here. And so in the second parameter after the comma, I'm going to enter in the brackets, I'm going to enter the actual names for the columns. So the first column, I call it, label, and then the second column is sentence, okay, the text data, right? So we can give it a try just to make sure we have the data properly, okay. Now, when we create a data, this is something I forgot. So let's assign the data to a variable. Okay, so data equal to this. This is going to create data frame, assign the frame to variable data. So now if you type data and run it, it should show the data frame. Of course, right now it just shows that it's a data frame and it has the data structure in there. We'll take a look once we get to a later stage. We'll take a look at whether our processing is working. So right now, what I would like to do, once we have that data, we can start to do some tokenization. And so remember, we have imported the tokenizer, so we can take advantage of it. So use the tokenizer, and then remember, in the tokenizer, it requires a couple of parameters. So the first parameter here, input column, is about which column do you want to use in the data frame, right, for this tokenization. So we only want to tokenize the second column here, which is the sentence data. So let's specify that as sentence, and then output column, we are going to create a new column for words. Okay, so this would be the new output column. Okay, and we can assign this to tokenizer, small case. Okay, or you can call it T if you want. Okay, let's call it T actually. So T is the tokenizer. Okay, and now you can use T as the tokenizer and then transform the data, right? So let's transform the data. Once you transform it, it should tokenize the sentence and output the words into the words column. So let's call the data words. Okay, so we run it, successful. Take a look. We can, okay, so if you just type words, it's going to show you that it's a data frame. It does not actually give you additional information. We can use this show method to show the actual data in words. So hopefully it's going to give you the data. When you run show or data collect, it's going to actually gather the data to this interface, and so that you will be able to present them to your audience. So you see that we have the original data with label and sentence, and after the transform with the tokenizer, we have the words. And you see the words are individual words, single words, in a set of brackets. When you see a bracket in there, that means it's an array or a list of things, okay? And they are also reduced to lowercase. So by default, the tokenizer actually also has this option of case folding, which reduces everything to the lowercase, as you can tell here. So that is the processing that is already built in as part of the machine learning library in the feature package. So now we have tokenized the data. We can continue to do some things interesting, such as, you know, for counts. Okay, so we can tokenize, but let's see if we can actually run the counts and vectorize, you know, and perhaps in the end we can say that the identify, you know, IDF, TF IDF for the term weights. Okay, so we have imported, as you can see here, the count vectorizer. Okay, so we are going to instantiate a count vectorizer and assign it to something like CV as count vectorizer. Okay, I'm going to put these you know, in one cell, okay, before I run it, but you can run it one by one just to make sure each one works. Okay, so the input column will be words, things that have been tokenized. Once they're tokenized as individual ones, then we can count them, right? So and then CV set output column. Okay, and we can output those as vectors. Okay, and so we are going to use CV fit, okay, on the words. Remember, we have the words data. Okay, so let's see. Yeah, okay, so we have the words data, and so we are going to use this count vectorizer, okay, to count or to fit. The notion of fit is to train this model on the data, and this is basic to learn the statistics from the data and get the result. Okay, so to build a model, and so once that is we apply the count vectorizer to the words, we can you know, learn from the data, run the statistic, and build a model. So we'll assign the result to a model, and then we are going to use the model to transform the words. Okay, and we are going to call this vectors. Okay, let's give it a try. Hopefully it will work. So it looks like it works. And so we know in the process of building the model and creating the vectors for the count data, the model must have captured something, right? So one thing that you can do is that you can use this model.vocabulary to show what vocabularies are in there. So as you can tell, the vocabularies is the list of unique words or terms from the collection: data science, SQL, Python, engineering, and R, right? So these are the unique terms identified from the collection. Now, we can also take a look at the kind of the top, take a look at the data. So if you, for example, just run vectors, right, it's a data frame, right? You show it, you show all the data, but we can also focus on vectors and select, because, you know, in the end we only want to look at the vectors data, okay, and perhaps just for the sake of demonstration, we can just pick the column, okay, we want to show, and then just list the top of the rows. Okay, so this is actually showing you the first row, okay, for this vectors column, and it tells you that it's a sparse vector. Okay, a sparse vector is where the values are only preserved if it's non-zero. Okay, so because you see in the first row here, right, Python SQL data signs, the term signs does not appear there, so but it's part of our vocabulary. So in this case, the vector is not going to preserve every single word in the vector representation. It's a sparse vector, so only those with non-zero value will be presented. So this 0 actually refers to the first term. Let me get my marker so that I can show you what I'm talking about. I think there can be some confusion here. So with my marker, so I think a vector representation is when you take each, let me set up my, so you see the model vocabulary, right? So right here we have a list of terms, okay, and we have 7 terms in here. So the first term for the first word here, data, this is index 0. Okay, this is the, so it always starts from 0 and then 1, 2, 3, 4, 5, 6, right? 7 terms, I'm sorry, and it starts with 0 and ends with 6. 0 to 6, right? So 0 is data, 1 is science, 2 is SQL, 3 is Python. If you look at the representation here, it's a sparse matrix. So 0, that means it's a reference to data, okay, because data appears once, right, in here, okay, in the first instance. Okay, so it has 1.0 represent value, okay, and then 2 is actually a reference to SQL, right, because SQL is here, okay, and then 3 is Python. Okay, so Python also appears. Okay, so this is the sparse vector representation. If you take a look at the third row here, you can also tell that it's data science and data engineering. So the word data, which is the first one, 0, appears twice. Okay, so even though this does not show you the complete data, it shows 2.0 here because data appears twice. So you can tell that this actually has done the correct computation and identify the counts for each word. Okay, the number of times each word appears in each of the data instances here. Okay, so I hope this makes sense. So I'm going to remove the annotation and we'll continue from here. So okay, so now the representation here, this is essentially term frequency. It's a very important count that counts the number of times each term appears in each document or data instance. Okay, you know, a classic treatment of term weights is inverse document frequency. Okay, so or if you combine both, it's TF, IDF. TF for term frequency, IDF for inverse document frequency. Now let's see how we can identify IDF as well. Okay, earlier when I did the import, you see I also import a module for IDF. So let's try to see it, use it right there. Okay, so let's start to do IDF. So you can call IDF, and let's see, the input column, okay, will be the vectors. Okay, so let's use the vectors, okay, as the input column, and then the output column will be IDF values. Okay, now let's assign this object or IDF transformer to lowercase IDF. Okay, and then what I'm going to do is going to use this IDF to fit the vectors data, right? So the vectors, and once it's fit, this is going to be the IDF model, right? So we create the IDF model, and then we use this IDF model to transform the vectors data. And once that is done, let's assign the result of this IDF transformation to IDF data. Okay, so run it, and it's done. Okay, so if you have the IDF data and show, okay, it has the vector representation, which is purely term frequency, but you also have the IDF. Okay, so for the inverse document frequency distribution. Okay, now, so this is kind of a simple process to utilize, the Spark and existing implementations in the machine learning library. There are also tools for you to implement your own, processes of computing. So I would like to just use another very simple example, just to show you how you may be able to do it from scratch in the parallel environment. Okay, so let me just start another parallel work count. Okay, so I'm going to just start another example here. Okay, and we are toward the end of this exercise. So here I would like to just show another example. So let's suppose we have some data. Okay, so you perhaps have words, and I hope do I have words already up there? I don't want to reuse it. Okay, so let's use words too. Okay, so words to equal to, for example, to be or not to be, right? So to be, it repeats. Okay, so we can use the split to split this string into multiple words, right? So, and then we take a look at the words, right? It's a list of the words in here, right? But this is if we do this in this way, this is basically just a regular Python process that takes advantage of the computing power within this notebook environment. It does not take advantage of the parallel computing. Of course, this data is very small, so you don't need the parallel computing power. But what if you have larger amount of data in the future and want to feed this into the parallel process, right? So earlier, we have take advantage of the Spark environment, the built-in features. Now let's see if we can continue to use the PySpark and and be able to use its parallel functions to compute things such as basic word counts. Okay, and we can implement our own process of doing the count. Okay, so let's import PySpark, and then remember we already have let's see, maybe I did imported it, but anyway it should work. The Spark, okay, is the connection that we already did earlier. So I just want to make sure, you know, in this line here that we already create the Spark connection, so we can reuse it right here. Okay, so we're going to use Spark context and assign this to SC. Okay, so SC now becomes the Spark context. Okay, because we need the context to be able to parallelize our computing. So right now, if I use this SC dot parallelize and then words 2, remember the words 2 is the list of words in here. Okay, of course right now it's all on this local notebook environment, but right now with SC parallelized, we are going to distribute it on the Spark framework, and that becomes something in the nature of RDD, or resilient distributed data set. That is the kind of the natural data set that Spark supports for distributed parallel computing. Okay, so once we have done that, we can assign the parallelization towards underscore RDD. So let's take a look. Okay, if you just type it, it says parallel collection RDD. Okay, so that makes it an RDD that is kind of the what Spark is built to process. Okay, and if you, of course, if you want to say I want to take a look at what is in the RDD, you can use this collect. Okay, you can use this collect function to collect it back, because if you have large amount of data, the RDD can be a very large distributed collection on that infrastructure. Unless it tell you to communicate back the whole data set, it's not going to do that, because sometimes it can be very expensive just to gather all the data back. So normally you want to collect the data at the final stage, once you have the final outcome that you maybe the result of your analysis, which is smaller to communicate back. You probably do not want to take a look at the entire collection, which may have hundreds of pages, hundreds of millions of pages if you are dealing with something at a web scale, right? So, but here it's a small data set, so it doesn't hurt. Okay, so we are collecting data back just to show you. Now, we have the list of data there. How can we run, implement something using the Spark framework, in the MapReduce kind of paradigm, right? So we know that Spark is really using the MapReduce framework for the implementation. So can we use mapper and reducer to do the job? So let's take a look, right? So right now we have the words RDD, okay, distributed, even though a very small collection. We can do a map, okay, and things can get more complex than that, but we can run a simple lambda function. Just think of it as a kind of inline function. When you take a value, how do you deal with it? So X is basically a representation for each key here, okay, and the key here in the case of a list of words, it's just each individual word. Okay, so for each key, once you see it, you are going to just emit value 1 because you see it once, right? So when you see 2, you emit the value 1 in the mapper. Okay, when you see B, you emit 1. And when you see the 2 again, you emit 1. So every time you see a term, you emit 1, just to say, I see it once, right? So as simple as that. And then, so once you have done that, you know, we can, you know, we can output this, perhaps I can call it 1 RDD, okay? So it's just a simple occurrence, okay, for each word. And again, just for the sake of this demonstration, let's collect it, okay, here. And you can tell, right, it basically attach one value to each key, which is a term or word here, right? Now we have the map, okay, which emits each value, okay, as a task. Now we need a reducer to kind of aggregate the values together, okay? So what we do here is that we can work on the words 1 RDD and continue from there. But what I would like to do is that I would like to actually repeat what I did earlier. So I'm going to copy the code here, and I'm going to call it word counts RDD. And it's going to based on the mapper as well as a reducer. So we know the mapper has emit each occurrence of the word, right, as key. Now we are going to reduce it by the key, okay? So lambda, okay, in the reducer, okay, because what is emitted from the mapper is this key value pair, right? So word and then one, word one, right? Or key one, okay? So we need two parameters a and b, okay? And the result should be sorry, actually this a and b is actually when the reducer is looking at when it has two kind of occurrences of the same key. We're going to add them together, okay? I think I misspoken. So we're going to add AB, right? So if I see two ones, and then the next time I also see two, I'm going to aggregate them together, okay? So that is what is going to happen here, okay? So we aggregate kind of when we encounter occurrences of the same key, we aggregate the value together, okay? And now we can take a look at the RDD, okay? And let's collect them and see if it has the result that we want, okay? So as you can tell from this process, the word count result has two occurrences of two occurrences of B, one occurrence of OR, one occurrence of NOT, okay? And this is, of course, if you do the manual computation just to, count them, this is correct, okay? But this is a simple process. This is just to, a simple demonstration to show you the process of mapping and reducing in the Spark framework, okay? So so I'll stop here just for the sake of demonstration. There's a lot more that you can do, obviously, with the Spark framework. You can use SQL. For those who are familiar with SQL, you can use kind of a SQL-like statements or functions to select data, to filter data, to aggregate data together. So that is another way to function, okay? As you can see, you can use the mappers and reducers, okay, within the Spark infrastructure to do the computation for you, and this can happen in the distributed parallel manner, okay, depending on how many machines do you actually kind of involve in the cluster. that you configure to be part of that cluster for your computing infrastructure. So the front end, how you code them, remains the same. You just need to change the configuration for your data distribution for your computing resources. Okay, and then there are, as you see in the first place, when I use some of the transformers, from the PySpark ML feature package, there are lots of built-in functions that you can just reuse. You don't have to implement on your own. You can simply just use the tokenizers, the vectorizers, the IDF, different even classification methods, clustering methods that have been implemented as part of the framework. Okay, so there are a lot that you can do with the Spark framework, and this is simply just a starter to show you how things can work from a notebook point of view in the Colab environment. I hope this is helpful, but if you have questions or issues, can be posted, and I hope to see you next time. Bye for now.